my god, what have we got here, huh? More bloody junk, huh? Can't believe people get me to repair this crap. Oh my god. At least I can use it to prop open the window, huh? When I'm having a smoke break. Actually, oh yeah, this is my own one. This piece of shit. Yeah, don't know why people use these noisy ancient mics anymore. This one, see, has a nylon capsule. What a pity. It's not got the original brass capsule in there, unfortunately. Anyway, let's open it up. Okay, 1, 2, 2, 2. Gain is cranked all the way on the Motu. When you tap it, as you heard in the audio sample, it's like there is a tiny bit of audio, like super thin, only high end. The microphonics start to show. And the thing is, what I have just found, which I was assuming might be the issue, the secondary winding coming out of the transformer to your preamp, out of the mic, that's fine. But the primary winding, which the microphone amplifier feeds signal to, is open circuit. Oh shit. And that means that probably the rest of the mic is working, including the DC to DC converter, which powers the capsule, the high voltage. The output cap is fine. I checked that in case that had gone short circuit, because it's a little, see, it's a little tantalum, this one here. They can go short circuit, and that would also cause some very weird issues. You might still get a tiny bit of sound. But anyway, okay, let's maybe we have to rewind the transformer or something. Okay, so a little bit of acetone, a few drops of acetone later, and the output transformer is free from the board. Just the two wires connecting to the XLR are remaining. So now we can start to inspect it a little bit better. Let's measure again. If we're super lucky, we have like, look. Okay, this black wire here, this one, you won't be able to see this. Let's see if I focus. This black wire is clearly broken here. It's been pinched. You can see because it's just flexing super easy. Okay, let's see if we get a connection. If we cut it at that break point, that pinch point, and strip it back. Okay, let's see if we get a connection. You have to be really careful here when you're dealing with wires, flying leads on transformers. Oh my god, if you pull them too hard, then they just pull out of the whole transformer and you're freaking screwed. Okay, where's my solder? No lead free around here, no way. We're far too conservative for that. Let's see. Okay, now, if we are so lucky, maybe we're gonna have a good mic repair week. Let's see. Yes, there we go, 37 ohms, beautiful. Okay, don't need to rewind the transformer. Okay, moment of truth. Moment of truth. Let's see. Oh, hello. Choo-choo. 2. Oh, it doesn't fucking work.
No.
What the fuck?
Told you.
Huh? Right. Okay, there's no power. Right, so now, seen as the open wire to the transformer didn't fix the issue, there's obviously a further issue. So, let's power this up again. Here we go. You'll see the microphonics of the transformer. Anyway, now I've got to check the amplifier circuit. So it turns out from all my rummaging around in the microphone from the start, I managed to disconnect a very flimsy wire going to the XLR inlet. Okay, so another moment of truth or lie, truth or failure. Let's see what happens now. 1, 2. 1, 2. A lot of buzz. 1, 2, 2. Yeah, it's working though. The thing is, when you power up a condenser mic without the housing, it's usually even worse than this. There's just an uncontrollable buzz and hum. So you'll see now when we put this over it. See? Straight away. 1, 2, 2. Okay, that's the back of the capsule. It's in cardioid. There you go. 2, 2. A little bit of buzz still. Let's see. Gain it up a bit. 1, 2. I mean, these are low output mics considering compared to modern condensers, but 2, 2. That's working. Okay, let's put it all back together and see how the noise floor is. We probably need to clean the capsule. It looks a little bit shitty. Some of you will probably be thinking, why didn't he change the capacitor, the tantalum cap, the output cap? Well, the thing is with tantalums, they're extremely reliable until the point where they self-destruct and short circuit, sometimes explode if there's voltage across them. The thing is, generally they don't degrade slowly like electrolytic capacitors. So if this was an electrolytic capacitor, I would change it for a same high quality one. But the thing is with tantalums, they also create a certain amount of distortion. Now, the thing is, tantalums were used in this era of audio gear because they were far more long-lasting and reliable than electrolytics. So therefore, the trade-off was, okay, we're going to have a tiny bit more distortion, but the thing is going to last. And in the grand scheme of things, during the tape recording era, the distortion that the tantalum cap was causing was almost negligible compared to the distortion from a tape machine or an old mixing console. So there you go. Yeah, so that's why I will not change it, because it's part of the sound of the microphone. If I change it to an electrolytic cap, it's probably going to sound ever so slightly cleaner, especially with digital recording where you can notice. So yeah, we usually with tantalums, particularly when they're in the signal path, like Orban equipment, a lot of that use tantalums. There's loads of others, Ampex, ATR tape machines. Anyway, that's a topic for another video. Yeah, so I'm not going to change it until it really fails. Also, I know I said before that I was probably going to clean the capsule, but I looked at it and yeah, there is some little bits of dirt on it, but the thing is, in my experience, unless there is actually some kind of noise happening due to dirt on the capsule, or the breath tests, if you like breathe on the capsule and if it cuts out or thumps and pops, then that means it really does need cleaning, because of course that's going to happen during a vocal take, or if you've got some humid weather going on. Yeah, so I think I will not clean this capsule. This mic is going to a local studio here, so I know them well, so it's not like it's going to the other side of the world. So of course, if it does develop some noise issues in the next months, then we'll bring it in and clean the capsule. Because also cleaning capsule can be risky. Some of the gold can start to lift away, the gold coating, and then it's a downward spiral. And yeah, let's give it a final try. Okay, and okay, 1 2 2 1 2. That sounds really good. The noise you'll hear is kind of the workshop. There's a lot of like HVAC systems outside the window. And 2 2, check. There you go. There's the rear. And gotta think of other things to say when 1 2. Omni. Yeah. Pad 10 dB. Okay. Figure of 8. 1 2. Yeah. There's the null point. There's the front. There's the other null point, and there's the back. Sounding exactly the same. Awesome. And then this other sort of hypercardioid mode, 2 2 2 2 2 2 2 2 2 2 2. So yeah, you see there's an extreme null point there, and then it comes back a bit. Yep, there we go. So I'm gonna leave that on for an hour or two, see if it starts to make some weird pops and squeals. That would also be a sign of a dirty capsule, amongst other things. And let's leave it on Omni, so both sides of the capsule are active. Now I can take these bloody gloves off. Yeah, I wear the gloves because when you're dealing with condenser mics, they're extremely high impedance inside, and more so with the older ones, you need to be really careful when you're opening them up, because if you touch parts of the circuit with your fingers and the grease and fat on your fingers, that can almost permanently affect the circuit and create all sorts of noise. More so in older mics, because they didn't used to. In the modern mics, they tend to seal away those super high impedance sections with resin. They coat them in resin to have, so that they're less susceptible to moisture in the environment, like condensation. The older mics didn't really do that. Anyway, so let's leave this one switched on and move on to the next mic.